So welcome everyone to this DBEI Insight webinar on data management. For those that do not know me, I'm Nathan Hildebrand, and in my day job, I'm an architect and director of my company Skewed, based in Brisbane, Australia. Now, I also dedicate my time as a volunteer for the Digital Built Environment Institute, or DBEI, and I'm the stream leader of the Built ANZ committee. So today it's my privilege to introduce this session to you. Now, it's a practical introduction to big data for construction and operations. Now, for those of you that are not familiar with DBEI, we are a global not-for-profit organisation and we service the AECO industry. Now, our goal is to improve productivity, efficiency and sustainability across the built environment. Now, to achieve this goal, we believe in the need to connect people within and beyond industry in a way that is independent of platform, discipline and geography. Now, our membership program is one of our key initiatives, which we aim to do just that. So the idea is first of all, we've got access to free webinars like this one, plus the ability to learn, grow and share with access to the resource hub, our document library and DBEI TV, our video library. So for those of you that want to improve your knowledge and learn from industry experts, I strongly encourage you to investigate the inclusions of paid membership on our website and join up to have 24/7 access to incredible content that our industry experts and leaders provide. Now, for those of you that are watching or using Zoom for the first time, I'd like to point you, or I guess make you aware of some of the features that we'll be using within today's session. So first of all, the Q&A. So at the bottom of your screen, we need you to move your mouse and click on the Q&A button. What we want to do is you to raise any questions you have throughout the session to the speaker in this panel. Please don't put them in the chat. That way, what we can do is throughout the presentation, our presenters could potentially respond to your questions, or at the end of our session, we can deal with it in Q&A. We've got the chat feature as well. So if you click on the chat button, it enables you to chat with other attendees throughout the whole process. So please make sure that you change the settings to all panelists and attendees rather than to panelists. Otherwise, the other attendees will not see what you're writing. Now, polls. Now, there will be a couple of polls that we'll use throughout this webinar, one from our sponsor and one from Luke and Michael. So please promptly respond to the poll when it pops up on your screen so we can move through the webinar and cover things as quickly as possible. Now, I'd like to thank our knowledge partner for today's webinar, the NBS, and our supporting sponsor, DeRofus, for their continued support. Now, here is a short video from NBS about their product, NBS Chorus. So thanks once again to NBS for your support. Now, it was great to see the announcement this week about NBS Chorus and the ArchiCAD plugin now being accessible to Australian users. So it's another great step forward in terms of a company being able to support the whole of industry in terms of the design profession. Now we're going to launch a quick poll, which should hopefully pop up on your screens. Now, we'll just wait a moment for people to quickly complete this poll and so we can move on with the webinar. But if you have any questions for NBS today, we have Michael Hogg online as well. And I can see Isabel's online as well today. So if you have any questions throughout the webinar, they're able to speak in the chat. Now we'll just wait one more moment until we'll give people another 30 seconds, Ellie, and close it out. And let's see what we're going to do. Ellie, are we presenting this poll, or are we going to just hold that for later? It's up there now. So that's some information, obviously, that MBS are keen to use to understand how they can help industry better. So let's close that out. So now I'd like to actually introduce our speakers for today, Luke Johnson and Michael Clothier. So Luke Johnson is a director at Virtual Built Technology and the services director for ANZ and Asia Pacific for Revisto. So Luke is an experienced architectural technician, BIM technologist, 3D modeler, and Revit specialist. I also like to see that he likes to go fishing on Twitter to see how many people he can catch in terms of controversial terms. But most recently, he's combined his construction knowledge with his technical expertise, working with general contractors, performing coordination and clash detection roles on several significant projects. His additional skills include Photoshop and 3D rendering for presentation, in-house and external Revit training, both hands-on and in a classroom environment, website design and maintenance, small business server maintenance, BIM hardware and software product development. And Michael. So Michael Clothier is a director and founder of Virtual Built Technology. So Michael had early experience in industrial design and manufacturing. He has brought the knowledge and expertise in computer modeling, digital information and technical workflows to the architecture, engineering and construction industry. So he's an early adopter of building information technology early on in an structural engineering office. And Michael recognised the benefits that it could bring to the AEC industry for providing efficiency, clarity, and a means for bringing about real collaboration for design, construction, and operations of a building. Michael's also the co-founder of the Revit User Group for South Australia. He's a frequent public speaker at BIM and Revit events and has trained hundreds of professionals and students in Revit and other BIM technologies. So now I'd like to hand you over to Michael to begin Michael and Luke's presentation. Thanks a lot, guys.
All right, thanks, Nathan, and thanks to DBEI for having us along. It's really cool to be a part of this, and hopefully we can bring some of what we know to you guys, and hopefully you can learn a little bit about some of the ways we've gone about our sort of introduction into big data. It's quite a journey, so we want to share that with you now. So let me just get this all working. All right, so yeah, like Nathan said, just keep the questions coming through. If you've got any questions, send them through. Luke is I'll be introducing Luke in a few moments time, and so he can answer questions while I'm talking, and vice versa, I can answer some of the questions while he's talking as well. So send those through. We're looking at big data for construction and operations, and so that's kind of a bit of an awkward title. Let's change it up a little bit and talk about knowing your building better, and that's essentially what we're trying to do here. Big data and the construction industry and the operations, FM, we are trying to understand a lot more about our buildings, and so what the big data is going to do is help us to know our building better. So what we're going to look at over the next hour or so is why we need to look at data. And this is, I'm going to labor this point a little bit because we don't know a lot of the reason why we need to look into this data. So we're going to answer that question, why we need to look into the data. What is a relational data schema? How can you conceptualize the data source on your project? And what's the difference between unfocused and selective analysis of BIM data? So first question is why? Why are we doing this? Why are we trying to know our buildings better? And essentially, this is about de-risking the project. You know, risk comes into play when we're unsure about something. So when we don't know enough about something, we're introducing risk. And when we're talking about de-risk, every constructor picks up their ears a little bit because they like to de-risk their projects. Buildings are really complex. Construction is very complex. There are so many elements to a building, and there's so much we need to know. So much that needs to be coordinated, so much that needs to be designed, cost, briefed, installed, and built. But not only that, there are teams of people that are doing this work. So it's fine that we need to know our buildings better. You only really need to know it when you need to know it. You only really need that piece of information when you need it. And so we're going to try and unpack a little bit about where we get this information from. But really, all of these things, this has just been really the big BIM promise. And it was promised a long time ago. You know, I've been in this industry a very long time, and we've been talking about BIM for a long time. And the BIM promise to the industry and the BIM promise to the clients and the governments and the mandates and all of that is this I in BIM. It's how do I know more about my building? How do I know how many elements there are? How do I know the quantity of concrete? How do I know the cost of the building? You know, it sounds all very obvious, but we as an industry have really struggled to answer this. And BIM has been a bit slow on its delivery of its promise. What is the I in BIM? And so we've probably heard many talks about this I, or the I in BIM. But it's all the information you need to know. And so this information part, this is the critical part. This is what you need to know, or to track, or to quantify, or to measure, or to cost, or to install, or to hand over. All of this information resides in the models. But it's more complex than that, because you only really need to know it when you need to know it. And so what we found is that much of this information, not all of it, but much of this information is in the models we already have. And so we do a lot of work for builders. Luke and I, with Virtual Built, most of our work, about 70 or 80%, comes from construction firms. And they employ us because they don't know what's in the models. They don't know what to do with it. And so they bring us on board to help unpack some of that. So I want to present this to you a little bit differently. We're used to 2D data. How do we interpret 2D data? We look at the drawings, and we have drawings to look at to understand something. To know about a building, we can look at the drawings. Well, that wasn't enough. And so we needed more than that. And then we brought in 3D. So we know how to interpret drawings, and we are very familiar now with how to interpret 3D. And to many people, 3D was what BIM was, you know, and how do we interpret this information? How do we interpret this data? Well, we walk through it. We pick up drawings, we walk through it in the model. And so we're very used to this. We're used to the 2D and we're used to the 3D. And if anyone's ever used Revisto before, they'd know that we can't get rid of the drawings yet. And I don't think drawings are ever going to go away. because there's so much information that are on the drawings that aren't in the model or aren't visible in the model. It's fine to walk around the model, but you can't. And so they're two sides of the same coin, right? And we know that. But there's this other equation that we don't get quite right. How do we interpret the I in BIM? What does the I look like? So we know what 2D looks like. We know what the 3D look like. What about all the data? You can look at a drawing, you can walk through a model, but how do I view the data? How do I read the information? How do I write this information? How does the industry interpret this new language? Okay, and so it is new, and we find it hard to read it. And we go to a building site, and the building, you know, the coordinator there, he sits us down in a chair and says, we've got these models. What's in there? What do we do with it? We have this BIM project. We don't know what to do with it. We don't know what it means. And so how do we interpret BIM? And this is a picture I've just added on the screen there of it's called the Rosetta Stone. And I think it was found in the early 1800s or something like that. And prior to the 1800s, they couldn't read Egyptian hieroglyphics because there was no way of interpreting it. It was a language that had disappeared. But this Rosetta Stone was 3 languages on one tablet. It was, I think, I don't know the full story, and I'm sure you didn't come here for a history lesson, but I think there was Greek or Arabic, and then there's the hieroglyphics. And so they were able to interpret Egyptian hieroglyphics based on the other languages. So we have 2D, 3D, and we've got this I in BIM. Now, why is it important? Because we need to know about our buildings more. I'll give you an example. The asset information in your model, we might have an electrical model, but we have a lot of asset information associated with those objects. Or we might have an asset information associated with a pump, mechanical pump. So I can see the pump in 2D, I can see the pump in 3D. How do I see the asset information? How do we interpret this new language? Now, no word of a lie, I took this photo on Friday of an architect who just delivered on ACONEX his model. He's smiling because you got no idea what's in the model. You can load it into Navisworks, but he's smiling because he's just handed over his model and the drawings and he's ticked the box, but we don't know how to interpret it. And so this is, he's happy because nobody else knows what to do with it. There is a problem though. Beyond reading it or writing it, that's not enough. Information for information's sake is not enough, and we need to turn the information into knowledge. Information is not knowledge. It's what we do with it that turns it into knowledge. And so we're coming up to this sort of point. This is where we're at. And these are the 2 problems we see a lot of. We arrive at a building site and the builder says, I don't know what I've got and I don't know what to do with what I've got. And so we're trying to solve that problem. It's a big problem. And it can give us great results if we can work this out. I can't interpret the data. I don't know what has changed in the model. I don't know how to open it. can we get a schedule of this? Can we get clouds around some of this information? You know, we used to cloud drawings. Can I cloud the data? How many of this thing is there? How much? I don't know. I don't know what to ask for. I don't know how to ask for the right information. But more importantly, how does this information translate into some sort of knowledge? What am I to know about this information? What's the plan? Where do I go to from here? And so this is where we got to. There's so much information in 2D and there's so much information in 3D, but there's so much more information that resides in the model that we can't access. Data that could be used for estimating, data that could be used for procurement, data that could be used for quantification, auditing, process tracking. There is so much there. Information that we need to know to cost, deliver, pour, build, and hand over. And so what we wanted a big picture, but a big data picture. How do I see this? What do I look at to see all of this information? And so I'm going to just take you back real quickly through our journey from Excel. So this picture on the left is 2013. How do I see the big data picture? And down the bottom here, I've got a note to start this poll. How do I start this poll? So what I want to know is, not started for me, is the question on the poll is, what percentage of your projects do you use Excel? And so back in 2013, our journey into this goes really deep. We're trying to use Excel to understand the models more. We build reports. We export out all of this data into Excel to build charts, to plot how the model is progressing. What do the objects represent? What does this information mean to me? What does it look like over time? What is the trend happening here? How does this translate to knowledge? How do I know more about my building? And we pushed really hard, and we really got to kind of the end of where we could get to in Excel. We started trying to present the data in more readable formats. How do you read the data? How do you interpret the information? What does it look like? And so we played around with different formats of how to read this information. Well, ultimately, we ended up with a problem. And the problem was Excel. Excel was too limiting. It wasn't enough. There was too much effort. And so some of these slides, I'll just go back. They are great to look at, but tremendous amount of work to get to where they show that information. It was distributed and decentralized. There was still no big picture. We still didn't have all the information in one place. And of course, there's always the difficulties of data loss when you're dealing with big data in a small format like Excel. So we got to the end of Excel. We couldn't push it any further. We needed something else. And so we looked into a database engine, and I'm going to just hand over to Luke now. We got to the end where we couldn't push any further. It was too hard. Excel didn't provide enough of what we needed. We learned about the need for a database engine. What are the relationships between the data? How does that work? What other visualization and tools could we use to present the data to the viewer? And so we learned all of this so that you don't have to. So I'm going to hand over to Luke now. Luke, you should be able to just take over the screen.
Yep. Let's do it. All right, cool. Thanks, Michael. I think what Michael's described there is probably problems and challenges that a lot of us have faced over the years. And, you know, in some ways we have built up really nice Excel workflows. We've spent a lot of time and it's become our little baby, right? This Excel chart, and maybe even we've done it into Power BI a little bit. But these are some of the core problems with Excel, right? Your data storage is limited. There's a set number of rows you can have in a spreadsheet. It's an abstract way of storing information. It's not like a piece of information should live in a certain space and be a certain format necessarily. You know, it's like go to cell B2. What does that mean? What's there? As you start to scale up and start to deal with more and more Excel files, that becomes incredibly difficult to manage and slower. Even if you're chucking them in a folder and trying to rip that data out and analyze it, you're still handling all these little files, and it's not a great way of doing things like historical analysis. And it's not a cloud-based kind of connected environment. And so all of those problems can be solved with a database schema, something that is in the cloud, something that is live, where we have virtually unlimited data storage. We can set up relationships, data structures. We can keep performance even at massive scale. We can do historical analysis, and we've got something that's integrated, centralized. This is where we put the data. This is where we analyze it. So what is big data? We're talking about an introduction to big data, so we don't want to go too deep on what Wikipedia says it is. But basically, we're talking about a field where the world is dealing with more and more information today. And how do you actually analyze it? How do you capture it, store it, analyze and visualize it? And some of those challenges Michael spoke about with at the beginning there, you know, they're real challenges that we've all faced as data grows and grows and grows. So when we get, when it talks about here, traditional data processing application software, you know, that's really Excel, isn't it? That's how we've done things in the past. And what we've pointed out is that Excel is not a big data tool. It just really cannot manage the process when we start getting bigger and bigger amounts of information. So as BIM guys, Michael and I, you know, we know about architecture and drafting and structural and things like that. We then had to go, you know, what is a database? How does this stuff get stored? How do we apply it back to construction and operations? And so we had to learn about these type of terms. We don't want to bore you with these details, but we had to learn what an object or document kind of storage method was, where basically you have a component and you attach different amounts of information to that component. And that's kind of okay, but it's difficult to analyze at scale still. And then you get into a relational database where every piece of information has a place to live in a structured way. Its certain type, you know, its data type is fixed. Its constraints to other tables are all fixed. And so now we're starting to drive a structure, something that can really be analyzed at scale. But then we have to talk about how this relates to BIM. And in BIM, we are kind of object oriented, aren't we? We've got a piece, you know, a table, we've got a wall, we've got a window. How do we start to abstract that into a database and attach information to it? And we have to talk about things like object to relational mapping, where we're mapping from here to here, the information. And so just one concept in object relational mapping that I wanted to talk about was this idea of entity attribute value storage. In Excel, if you've ever had to deal with, you know, data that's very complex and starting to grow, you end up with lots and lots of columns, don't you? And it gets to the point where you just can't even manage the amount of columns that you've got. And so how do you actually store that data when we talk about big data? And the answer is you pivot it and turn it around, and you do entity attribute value storage, where in this example here, we've got a Revit ID, and we've got a parameter name and a parameter value. And we've also stored a logging or kind of time key there. And then that table can just grow longer and longer and longer the more information we want to store. It doesn't need to get wider, because it only needs those 4 or 5 columns, and we can store stacks and stacks of information in that structure. And so we had to design a schema, which was really the core or the backbone of DeepSpace as a platform and a tool that we built, Michael and I, together. So each person who uses DeepSpace has their own workspace. Within their workspace, are projects. Each project has multiple teams, and the architectural team, the mechanical team, these different disciplines working on it. Each one of those teams can have multiple BIM files that they're contributing to the environments. The Revit architectural facade model and the Revit, architectural interiors model, and so on. And then what we're starting to do is rip data out of these files into the DeepSpace schema and maintain all historical information. And so we have the ability to rewind time and go back, this is what the data looked like back in time, or this is the current data set. What does everything look like as of today in the project? So just a quick a point to think about is this storage comparison, where Excel taps out at about 1 million rows. The engine that we're using inside of DeepSpace, we've basically got theoretically unlimited data storage. It's the same engine used by NASA and Amazon and Netflix and so on. And so already in the platform, we've got just in one table across multiple schemas, we've got 1.7 billion rows of data that we can analyze and check historically. So how did we start to apply these things to real projects? This is a case study. We built DeepSpace when we were part of a delivery team on a huge hospital project. We were working closely with the project BIM manager, and we were there through construction and into the construction to operations handover period. And so there were multiple data sources in play. We had a massive Revit data set of about 800 Revit models, and they obviously wanted to use this for FM. So they had a couple of FM tools and the Revit models, and we, using DeepSpace, we put all this information into that structured environment, and we could report back and say, roughly 1/3 of your data is in all the environments, and 2/3 of it is only existing in the FM tool, for example. And then we could break that down further by disciplines and by models and see who is basically contributing valid data to the federated project. And even in that construction to operations handover period, there were still multiple data sources in play. And one thing that we wanted to keep in mind or to be aware of with DeepSpace was that it was not going to be something that was going to replace a heap of other ways that people were doing things. What I mean to say is, Revit was still going to exist and people were still going to do modeling there. And a tool like Revisto was still going to be the right place to do collaboration discussions. And Aconex may have been the right place to do document control. But what's this environment that can talk to all of these pieces and achieve some task, some goal, some piece of work that we wanted to do? We really needed integrations into each one of those platforms that were live, that were operational. So for Revit, if we wanted to be able to analyze this massive data set, we needed to be able to rip the data out quickly and store it in a safe, secure place where we could give out permissions and access and so on to it. And so we set out to build this Revit add-in. We coded a lot of it pretty raw in the beginning, and then we engaged a developer to then put the polish on this and turn it into a Revit add-in for us. So I'll give you a real quick look at that, what that looks like. Here we are in Revit 2020. We've got our plugin here in the ribbon. This model, this data set has already been connected up to the Deep Space cloud, and we can click on the analytics button here, and it basically gives us a dialog which says, hey, this is where your data is living. This is all the key IDs to be able to call up your information in Power BI or some other analytics environment. We can configure the connection between this model and the cloud, and we can sync. So if we go to sync, it opens up this dialog here where we can say, I want to publish the federated model, the architecture, the structure. We've got some options about data that we want to capture or not. And even this was a bit of learning over time, what was going to be too much for most people in terms of data. So this one here, for example, maybe you don't want to collect every single parameter on every single piece of text in the model. And that is really it. We can now just hit engage, and the plugin is ripping data out of all those models, publishing it to the cloud into a structured environment, and we can go away and analyze that. We'll jump back into our spreadsheet here. We also had the Revisto data operational on the operations side. They were using it to manage the project for FM. And so we created an issue data integration where we were pulling information from Revisto into Deep Space, and we could then analyze that in conjunction with the Revit information. And the number of integrations will continue to grow in Deep Space so that we can analyze all this information together. So this is what we kind of ended up with in that particular case study. The client had done some work in Excel, which we could publish into Deep Space. We had the Revit Deep Space sync publishing into Deep Space, and we had the Revisto integration. We also were able to address some of our data in Dynamo if we wanted to do writebacks and other things. So we had this, I guess to me, it was the dream, because now I had an environment where I could get things done that I could never get done before at scale in a really powerful platform. And we could do things like this, of course, data auditing and rectification. We built things like a uniformat mapping tool where we could just quickly run scripts and automate all the classification of elements. We built some customized interfaces for the client. In this particular example, we brought in data that they had about their electrical systems, linked it all together to the Revit information and to Revisto, and ended up with something like this, where inside the Revisto environment, we could jump into a particular element, and we could also jump back out into the database. So we had kind of a three-way linkage operational, between data, the 3D model, and the collaboration tool. A little bit like what Michael was talking about before, that Rosetta Stone, where we could now kind of get everything talking to each other in a way we hadn't been able to in the past. I think this is a short video here of that. Basically, inside of our front end, browsing through this data that the client has put together in Excel, clicking a hyperlink there, which is launching us straight into Revisto, reviewing some of the context of that element inside Revisto. And then when I want to jump back into the database, I can just click on the hyperlink there, and that puts me straight back into that element, inside the database. So we had that, bi-directional linkage operational. Just some lessons, particularly from the operations side, which I'm sure many of you are already learning as well, is you need to have a clear, standard in terms of what you're going to hand over at operations time in your data. And you need to be able to validate that. And that's, I think, a key thing, is the validation of those handovers is traditionally very difficult. Even if you're doing it in, some kind of Excel setup, maybe exporting Revit schedules, parameters are called different things. Parameter IDs, are changing. It's just too difficult to manage with an export file situation. We need to get that data into a relational database. We need to get it into a data platform. So once we've got it in that platform, we can validate and audit. We can enforce the rectification. So we can either issue reports to say, hey, you didn't do your job in terms of meeting the project requirements. Or, in some situations, we take ownership of those models and just automate the injection of data and fix that problem for people. So this is what we ended up with, a schema for the whole project lifecycle, where we could slice this information. We had it live. We could use it on a mobile phone. We could, take it in our hands, viewing all this data, which was really cool as well. Massive data sets. People talk about the digital twin a lot, and we didn't talk about it much today on purpose. But basically, on the journey to the digital twin, this data platform is going to be a key piece as well. Because until you can validate the whole design and say, this is the truth about the data, this has correct parameters, correct classification, a lot of the uses of a digital twin just won't work until you can get that data cleansed correctly. And so you need that platform to be able to do it. We have, of course, built many dashboard templates over the course of this, development in building deep space, right from the workspace level, where we can say, let's compare project to project and see which team is coordinating better, which one is doing better Revit modeling. We can, at the project level, say, which discipline is meeting the requirements. Let's distill the whole discipline down to a score and say, fire's doing a good job and mechanical's not doing a good job in terms of meeting the project BIM requirements. At the model level, we can deep dive and say, how many of this type of element in a 2D view, in a 3D view do I have? So think about these visuals. Michael was talking about before, we don't know what we've got. And as a constructor or a building operator, this BIM stuff is scary because it's all locked away in some authoring tool like Revit or ArchiCAD. Whereas what we're saying now is just instruct your teams to rip the data out for you into your deep space environment, and then you can have a simple visual like this, which gives you that view. Are you interested in parameter auditing? Well, here's a dashboard for that. Are you interested in tracking how much steel has been installed in your project to date? Well, here's a dashboard for that. So we've spent a lot of time, because we spent a lot of time building the structured data schema, the dashboarding is not complicated. It's something that we can handle because we know where the information is. We know we can call up historical information. We can trend line things. We can score things predictably. What about comparing two different data drops? This one here is, this is the model information on one date. This is the next date. And what's the delta of change in quantities between those dates? There's no heavy lifting involved there. The teams have just pressed sync on the Deep Space Sync plugin a couple of times over the life of the project, and we've hit refresh on this dashboard, and you've got that insight. What about this one down here? You want to check the return on investment for your clash detection process. And so we can do that. We've got this dashboard for return on investment specifically. Trending, the quality of models over time, trending coordination, reviewing quantities, searching for specific model disciplines and so on. We can do all of that with different front ends and different dashboards that we've put together. Cool. What's next? What's next for Deep Space? Well, we have had a dream over the past few years that's it's coming to fruition, but there is the next dream, which is automation, machine learning. Because we can now collect structured data at scale, we can do some really interesting things with it. We can create a system like this where we can automatically classify model elements into a classification scheme like Uniformat or something. We can map attributes between the classification scheme and Revit and say, that one should come automatically from Revit and that one should be filled out by the project team. And this is how far you've got along that process on the project. So the more data that we collect like this, the more value we're going to be able to provide as a platform. So I think that as construction and operations and design firms, we need this next-gen data management platform. It's the next piece in the puzzle. We've done 2D, we've done 3D, we've done even 3D collaboration and clash detection. But where is that next engine? Where is that next solution to be able to do big BIM data analysis? And as you've seen today, that was the journey of Deep Space, getting to that point where we had that in our hands. So as Michael said at the beginning, it's time. It's time for us to know our building better. And aside from all the complex schema type design stuff that I've just gone through, that goal is really the goal of Deep Space, enabling people to know their building, to know their design, to know whatever they're putting together in this BIM or environment. We're giving them a window into it, transparency to analyze and report on it. And that is the end of our slides, guys. That's the end of our presentation. So I think we have a few minutes now to switch over to question time.
So before I jump off and start launching into questions, I'm really keen to see our attendees come forward with some questions in the Q&A section. I'm just seeing quickly here. Michael Hoggs talked about you're both painting the picture very well, so we'll call you Michelangelo today. In and around BIM maturity within the supply chain here in Australia, design teams have moved across to 3D models and originally considered that BIM. However, this is simply making a 3D model data heavy, with a lot of the data not being used for any significant decision-making processes, etc. So I think that's more of a comment rather than a question, but any questions from anyone, please post them up in the Q&A thing. But I'll start off asking you guys a question. Now, obviously you've created this new platform in Deep Space. How important do you think it is moving forward, obviously transforming and moving forward from essentially just having pure data to a scenario where we're actually talking about information? So thinking about these two new ISO standards that have been released only the last couple of months, and that's 23386 and 23387. These two ISO standards talk specifically in and around data dictionaries and data templates. So trying to bring together essentially, commonality or common naming conventions across the globe for naming conventions. How important is that moving forward?
I think it will be important. I think some regions will do that better, just by virtue of how the industry looks and the mandates and so on. But in other industries, they're going to always want to do things their own way, and then kind of at some point in the future meet the requirement, or like at handover time meet that requirement. So I think there's going to always be a bridge between the way people's are authoring and the way they have to deliver something, because quite frankly, you're never going to end up with the whole world modeling in the same way with the same content. I guess that's my personal opinion on the future.
Well, it begs the question, because a lot of manufacturers are out there creating all this content, and the content, in my opinion, is not really fit for purpose moving forward into the future. They've wasted substantial amounts of money producing these 3D models, which essentially assist in the processes we've talked about in regards to geometry and clash detection. It doesn't step forward into the necessary things in regards to having structured, consistent information, which is actually going to be what drives efficiencies across industry and connectivity. Right now, we've got scenarios where if we start creating big data, if every single silo creates their own big data, I've had conversations with people about digital waste and black data. How do we create better connectivity and access for all of the different actors that form the delivery of a project across the design, construction and operation of an asset lifecycle. What's your thoughts on that? How can we achieve this? You know, people like talking about digital twins, but let's get the information right first.
Yeah, so I think what you're describing is a future where there's some API or there's some, you know, there's some language that everything talks together, you know, and you can analyze something in that environment, and that might be a real future. But I think until we get there, capturing data is still good, even if the data is not good, if that makes sense. Because so what I'm getting at is that black data, or maybe it's junk, or maybe it's got manufacturer parameters in it or something. Until you're putting all that in a repository where you can analyze it and tell the manufacturer, look, just get rid of that piece of data, or that's wrong, or until you can actually give that feedback at a massive level, you really can't take those next steps towards standardization. So I think, you know, a repository or an API or a language of talking about this is what an element is, you know, this is what an element ID is, and this is how the parameters map to that, and all that kind of stuff will continue to grow. And I guess Deep Space to us is part of that journey in being able to standardize things across industry.
So moving forward, I think a big challenge with this, the volume of information that we're going to have, and the number of numerous different contributors that are going to be building up this information for the delivery of an asset. How do you see platforms adapting to accommodate this? So, for example, authoring software probably should more so only hold a GUID, or, you know, information that's required to produce a specific documentation output or information output, but then an external database holding the remaining material or information. You know, we've got to think of how the information may be important for construction, but that information for construction isn't relevant for the majority of the maintenance of the asset.
Yeah.
And, you know, how does a subcontractor feed information that he has to deliver at the end of a project as part of his digital deliverables on top of his built asset in terms of the building work he's doing?
Yeah. When BIM came along, there's that picture, the graph that Autodesk brought out, and it's, you know, all these different life cycle parts of the building, and in the middle of it, they're all pointing to this arrow called BIM. And it took us a long time to realize that that thing doesn't actually exist, because there is no single point of truth. You know, what they've described, what Autodesk described, is this kind of utopian idea, but in reality, there is multiple versions of truth. You know, the concrete column has got MPA from the structural engineers, has got a paint color from the architects, and has got a conduit in it from the electricians. And so like, we need to know all of that information, but they kind of come from different sources, and we just need to be able to, like, slice it together and stitch this kind of this Frankenstein-looking digital twin together, because the digital twin gives this illusion that there is one point of truth, that it is a mirrored version of reality, but that's not quite true, because, you know, you walk around a site office and you see all the builders and all the contractors. They've all got their own Excel trackers. They've all got their own, you know, model that they've hacked up, and they're trying to edit things. And there's just so much disparate information. There's no way to pull it all together, because the thing doesn't exist.
Oh, I think though, in that discussion point though, it demonstrates, you know, and it kind of ties me back to ISO 19650.5, where we're talking about security settings, right? So, for example, we have, you know, 100 parameters attached to a construction element within a model, and let's just assume it's dumb. Right now, we've got a model, and that actual native software has 100 pieces of data. Some actors throughout that process do not have the security clearance, or shouldn't be seeing certain pieces of data. So therefore, there is substantial benefits in having disparate connected systems, which then enables this community, but they all talk to one another, but they have their own unique piece of information they do which they do for their own portions and parts. It's kind of similar to how structural steel strop drawings, for example, are really important with that level of accuracy to 1 millimeter tolerance to enable it to be built and manufactured. But the second it's manufactured, the tolerance requirements for someone maintaining that asset is far less. And that's kind of, I guess, he has that level of information to enable him to construct. Then he only needs to hand over a slither of information to enable a certain aspect of that to move forward. And don't tell me you guys are also on the digital twin front when it comes to just virtual representations. I hate that. I can't cope it. The digital twins all connected by sensors. Don't do that to me. But I've talked too much. Come on, I want some questions from our quiet audience out there. I know there's a lot of you out there, but you're just sitting there very quiet. Another thing, I guess, a question, I guess, kind of moving forward. Obviously, the conversation today was a lot around the process of authoring information. How do you see this playing out in the construction space? How are the processes that you've set up in Deep Space right now going to facilitate and make the lives easier for people in construction in terms of data and information gathering and compilation?
Yeah. So firstly, it's like we give them insight into what's there and what's not. So, simple dashboard tells them how close they are to meeting their data requirements, and that allows them to feed that back to the subbies who are usually engaged and mandated to actually do that. Then we've got basically tools where we could set up a portal for them to enter some of that data in, and you could outsource the data entry piece and get that happening through a web interface and then fed back into the model. So we're definitely on the same page in terms of there is no single point of truth, and I don't think there ever will be. There'll be multiple things that are merging together, but there needs to be a platform that kind of understands the connectors between all of these to be able to merge that information and give you back the truth kind of thing.
Yep, that makes sense. So we're probably just about ready to close. Had a very quiet audience once again, which, I like a bit of banter from the audience, but I'm assuming they were probably too busy listening to you guys rather than chatting, which is probably a positive in some ways.
I think they were just jumping on the website and putting in the credit card details, mate.
Well, if in any case, you can catch Luke on Twitter and go fishing with him one day. But thanks very much to you, both Luke and Michael, for your presentation today. For everyone here, the recording of this webinar will be made available to you at this time tomorrow, and it's going to be available for you to watch for the next 7 days from today. Please don't hesitate to share it with your colleagues and peers that they might find this information valuable to their professional development. And for those that actually want to continue to watch the webinar after this period, along with the extensive library of other presentations and content, I actually recommend that you investigate taking out membership with DBEI. Now, we are strong believers in producing great content. So to assist us to achieve this, we would really love your feedback. So I know it takes an extra 30 seconds, but once this webinar closes down, could you please take a moment to fill in the survey that will pop up in your web browser at the end of this webinar? So it'd be greatly appreciated if you could do that. If you have any questions that you were too nervous to ask during this webinar, you can actually go into the DBI community and post those questions in the community, or both Michael and Luke had their contact details up on that last slide, and you could probably contact them directly. Now, I'd like to thank our knowledge partner for today's webinar, NBS, and Michael has kindly put up a link to their Chorus product on their website. And I'd also like to thank our supporting partner, DeRofus, for their continued support. I'd like to thank you guys out there for being quiet and joining us today very pleasantly. And I encourage you to sign up for our next global webinar series on legal. Now, this series will open up your eyes and provide you with some insights on how to keep you out of jail, which is always important in our industry. Keep a lookout for our What's On emails in your inbox for future presentations and topics. And we look forward to welcoming you at our next ANZ webinar on sustainability on Thursday, the 29th of October at 1 p.m. Australian Eastern Standard Time, I hope, unless it's changed over to daylight savings and we might find something else. But anyway, I'd like to thank everyone for attending, and have a wonderful afternoon. Thanks a lot.
Thank you.
Thanks, everyone. We'll see you later.